Hello friends. So we'll see the terminologies which are used in system of limits and fits. The first term is a shaft. So shaft means what, hole means what, basic size, actual size, all these definitions we'll see one by one. So the first definition is a shaft. Then the hole and all other sizes. So the size means the component dimension we are measuring and we are expressing it in a number. Now the designer, whenever he designs one component, so he gives some basic dimension for it. Based on the calculations he does, based on the strength of material equations or the machine design equations, so he is getting one dimension. So that is called the basic size of the component. And the actual size of the component is the size that we are getting manufacturing, and after manufacturing we are measuring on it. And as said earlier that we cannot manufacture the component to the given size. So what we are saying, the limits, we are setting some limits which is the permissible limits of the part. That is the maximum limit and the minimum limit of the part. That is the maximum permitted size of the part and minimum permitted size of the part. Now hole and shaft, we are going to refer these two terms in our discussion hereafter. But hole does not means only the internal dimensions, or hole does not means a circular hole. So any kind of internal dimension is called as a hole. It can be a recess, it can be a channel, whereas shaft does not only means the shaft. So any kind of external dimension, maybe a rib, maybe any projection is called as a shaft. And these two definitions we are going to use because it is easy to understand the system of limits and fits with these two definitions. Now we cannot manufacture the part to the given size. So what we are giving some permissible variation in the dimensions. And this permissible variation in the dimension is called as a tolerance. And as we have seen, there is a maximum permissible limit and minimum permissible limit. So the difference between these two limits is called as a tolerance. So this is the maximum limit and this is the minimum limit, and the difference between these two is called as a tolerance, and this yellow zone is called as a tolerance zone for it. So for example, if you take this example, this is the basic size of a hole which is given by designer. So 28 mm is the basic size, but we cannot manufacture to this size. So what we are giving some tolerance plus or minus 0.2. So the minimum limit or the lower limit of the hole is 27.8 and the maximum limit is 28.2. And the difference between these two, which is 0.4, is a tolerance. And this zone, which is shown by this violet line or color, is called as a tolerance zone for this component. And there are different types of tolerances, limits are there. That is the unilateral tolerance and bilateral tolerance. If you see the unilateral tolerance, the tolerance is given on only one side of the basic size or a zero line, because this basic size is also called as a zero line. So if you are giving the tolerance on the positive side only, it is called as a unilateral tolerance. Or if you are giving tolerances only on the negative side, it is called as a unilateral tolerance. But if you are giving the tolerances both on the sides of the basic size or the both sides of the zero line, that is plus minus 0.2, plus minus 0.1. So that type of a tolerance limit is called as a bilateral tolerance system. So allowance is again a very important definition. So allowance says that it is the intentional difference between the maximum metal condition of the hole to the maximum metal condition of the shaft. Now what is maximum metal condition of the hole and what is the maximum metal condition of the shaft? So maximum metal means where the material is maximum. So in case of a hole, if you see, when the lower limit of the hole is there, then the metal will be maximum, because as you increase the size of the hole, the material will be reduced. Whereas in case of a shaft, it is vice versa. When the shaft size is bigger, then the material will be maximum. So when we are calculating the allowance, we are calculating lower limit of a hole minus upper limit of a shaft. And that value, the difference, is called as a allowance. So allowance is also very important because this allowance will give the relationship between the mating parts. It will decide that whether we are getting a interference fit or whether we are getting a clearance fit. But what is fit? So fit is nothing but the interrelationship between the two mating parts, or the relationship between the two mating parts. So if you see here, this pen cap and this pen is having some relationship. So there is some fitment. Initially it is a clearance, then it is becoming a interference fit or a press fit. So this fitment or the fit is divided in different types. So the first type is the clearance fit. So in clearance fit, the maximum size of a shaft is always smaller than the smaller size of a hole. Means always there is a gap between the hole and shaft. And the example for this clearance fit is a piston and cylinder. We require some clearance between this piston and cylinder such that we can get the movement. But that clearance should not be more, because if it is more than the required, then that lubrication film will not withstand. And if it is less than the required, then the possible metal to metal contactability takes place. In interference fit, the minimum size of the shaft is always bigger than the maximum size of a hole. So this shaft is always bigger than the hole. So always we are getting an interference fit in this. And the practical example of for the interference fit is any push fit, any press fit. So that type of fits are the interference fit. So if you want to put a gear on a shaft, it is a interference fit. Because if it is a clearance fit, then the no motion or power transmission will take place. And the third type of fit is, which is very interesting fit, that is called as a transition fit. But this transition fit does not exist in practice. It will be either a clearance fit or an interference fit. Then what is a transition fit? So in transition fit, what happens? The tolerance zones of the hole and shaft will overlap. So when tolerance zones of the hole and shaft will overlap, so if the tolerance zones is overlap, for example, this case, if you see, initially there is a clearance fit. But as soon as we are putting it forward, so we are getting interference fit. Means sometimes it will be clearance fit, sometimes it will be interference fit, depending upon the actual dimensions of the part. So that is called as a transition fit. But transition fit does not have any practical application, because it will be either a clearance or interference fit. It is only have the theoretical importance for us. So this is the some figures by which we can understand that what is a clearance fit. Now we can see over here that in clearance fit, maximum size of a shaft is always smaller than the smaller size of a hole. Whereas in case of interference fit, smaller size of a shaft is always bigger than the maximum size of a hole. Whereas in transition fit, we are getting the tolerance zones overlap to each other. The same thing which is shown pictorial by using this different types of fits. So you have seen the definition for the clearance fit, interference fit and transition fit, and which are used in various practical examples. Then there is one more definition is that which is called as a deviation. So deviation is nothing but the algebraic difference between the basic size and the actual size. So for example, upper deviation, it is the algebraic difference between the maximum limit or the upper limit of the size and corresponding basic size. And the lower deviation is the algebraic difference between the minimum limit of the size or the lower limit of the size and corresponding basic size. And the fundamental deviation is either the upper deviation or lower deviation, which is closer to zero line. If you see here in this hole and shaft example, this is the minimum diameter hole, this is the maximum diameter hole. So and this is the basic size for it. So minimum diameter and corresponding basic size, so that will give the lower deviation. So this much value is the lower deviation, whereas maximum limit and corresponding basic size, so this is the upper deviation. And very clearly we can say that which deviation is closer to zero line, lower deviation is closer to zero line. So it is called as a fundamental deviation. The same thing which we have seen is shown over here, that is what is upper deviation, what is lower deviation, what is fundamental deviation. So for example, if you take a case of a shaft, this is a minimum diameter shaft, this is the maximum diameter shaft, this is the basic size for the shaft. Basic size for hole and shaft is actually same. This is also called as a zero line. So now maximum diameter of the shaft and the upper deviation and the basic size is called as upper deviation. Minimum diameter of the shaft and the corresponding basic size is called as a lower deviation. Now here upper deviation is closer to the zero line, so this upper deviation is called as a fundamental deviation. This hatching region which is shown, is the difference between the maximum and minimum diameter. It is called as a tolerance. Now one more thing that is very interesting, very important, and that we are going to see in next class, that is when you are drawing some manufacturing drawings, then we are using some symbols here like 32S7 or 25S7 or 32N6. So all these symbols are derived from the system of limits and fits. So what is the meaning of these symbols and how to interpret these results from these symbols, that we are going to see in next class. Thank you.